recording. The mic is on. Okay, so 6.4, y'all, it talks about proportional reasoning. And again, just to give you guys a heads up, what I did here, y'all, was I just did a quick Google search, and this is for the state of Texas, and we're obviously in Texas, and unless you're planning on moving somewhere else, this is called the TEX, so it stands for the Texas Education Agency. But when I pulled it up for sixth grade right here, this is like the general assessment. One of the things that you would do if you're teaching sixth grade, or if you end up with a sixth grade class, is you're going to end up doing proportionality. And that's what today's section covers, okay? So again, this stuff is more for the junior high age group, but again, in case you get one, you want to be able to decide what you're going to do. So first thing we're going to do, talk about the definition of a ratio. A ratio, y'all, is just a fraction, A over B, and whether you write it like, let me get my pen going here. Okay, and come on, pen. Here you go. And whether you write your fraction A over B like this, or A over B like that, and sometimes we write it like this with the word 2, A to B, that's what a ratio is, okay? It's just a comparison of two quantities, okay? Okay, so we got a couple of problems here. And the first one says, determine the ratio of vowels to consonants. Okay, so we're talking about the English alphabet. Okay, now, guys, I don't know about you, but the last time I kind of studied the alphabet was, I don't know what, kinder, first grade. Number one, anybody remember how many letters are in the alphabet? 26. Okay, good. So we got a total of 26 letters. Okay, now the vowels, y'all agree the vowels are A, E, I, O, and U. And sometimes we say Y is, and sometimes we say it isn't. So we're going to just go with those as the vowels, okay? So, y'all, question, how many vowels do I have? 5? Okay, so we have 5 vowels. Okay. All right, now my question to you is, if there's a total of 26 letters and 5 of them are vowels, and I can't even spell consonants because I haven't studied that. I haven't even heard that word since kid. That's an O, A-N-T-S. Okay, so look, y'all, if we got a total of 26 letters and 5 of them are vowels, would you guys agree 21 of them have to be consonants? That's what's left over, right? Okay, so look at this. Write the ratio of vowels to consonants. Okay, 5 vowels to 21 consonants. That's all we're doing. A ratio, y'all, is just a fraction, okay? Now, if I look at part B, write the ratio of consonants to vowels. Okay, I'm just going to do it the other way. 21 over 5, okay? All right, part D says write the ratio of consonants to letters. So look, we have 21 consonants, but we have a total of 26 letters, right? Okay, and then part D, D as in dog, says write a word that has a ratio of 2/3 of vowels to consonants. Okay, so guys, when they're telling me 2 to 3 vowels to consonants, okay, what they're telling me is that we want to have 2 vowels and 3 consonants, okay? So this is a multiple choice question here, y'all. So all I'm going to do is I'm going to look at my choices, and I'm going to say, okay, well, look, if I have 2 vowels and 3 consonants, that's telling me that I'm going to have a total of 5 letters, okay? So I'm going to look at my choices here, and I'm going to say, okay, which ones have 5 letters? 2, 4, 6, that's too many. 1, 2, 3, 4, 5. Okay, so this could be 1. That's 4 letters, I know that. 1, 2, 3, 4, 5. Okay, so I got 2 choices here, y'all. My choices are either going to be minor or chord, okay? So which one has 2 vowels and 3 consonants? Doesn't minor have 2 vowels and 3 consonants because I and O are my vowels, and M, N, and R are my consonants? So I would choose minor, right? And that's all I'm really looking at here, okay? All right. Yeah, I don't remember the last time I heard the word vowels or consonants. But anywho, okay, the next part here, y'all, is, again, this is more for, like I said, like the 6th grade level. But it says if A, B, C, and D are rational numbers, and B is not 0 and D is not 0. Okay, what this is saying, y'all, is that when two fractions are equal to each other, we call that a proportion. And it's a proportion if, when we multiply diagonally, sometimes we call it cross multiplying. When we multiply diagonally, those numbers are going to be the same, okay? So again, y'all, if I was teaching a group of 6th graders and it says, look, solve for X in each of the following proportions, and I was doing part A, I would say, look, we have 8 over X, and that's equal to 48 over 42. So I'd say, well, look, those two fractions, they're telling me that they're equal. Well, because they're equal, we can cross multiply. So I would take my calculator here, let me move this to the side, and I would say, look, figure out what's 8 times 42. Let me move this a little bit. Okay, 8 times 42, y'all, is going to give me 336. And then I'm going to multiply here again. X times 48, that's going to give me a 48 times an X. And I would probably put that little dot there just so that I can let the students know, hey, look, I'm multiplying here, right? Now, since I'm trying to solve for X, I want to undo the process. The way I undo the process is if I'm multiplying, I'm going to do the opposite, which means to divide. Okay. And I would take my calculator and I'd say, look, what's 336 divided by 48? And we'd end up with 7, right? But again, this would be my approach. This is how I would walk a 6th grader through this kind of lesson, okay? And then we'd say, okay, look, guys, let's do this again. So look, I'm going to do part B. I'm going to write X over 7 is equal to a negative 5 over 29. And I'd say, look, we're going to do the same thing we did before. We're going to cross multiply, okay? So X times 29 is going to give me a 29 times X, okay? And we're going to multiply here. And I would tell my students, look, y'all, a positive times a negative is a negative number, and 7 times 5 is 35, okay? And then we would say, okay, look, y'all, what's the next step? Well, if I'm multiplying, the opposite of multiplying is to divide. So I would divide everything here by 29. And if I can't reduce that fraction, which in this case I can't, right? And 29 doesn't go nice and pretty into 35, I would just leave it like this, right? And I would tell my 6th graders, it's okay to have an improper fraction, and it's negative, but that's just the answer that we end up with, okay? All righty, let me go ahead and go to part C. Okay, oops, I'm gonna move it over here to the side because I don't have a lot of room. So apologize, I should have put more room. But let's see, look, we're gonna go 5 over 6 equals 4x over 127. And I tell my students, okay, look, let's do this the same way. We're gonna cross multiply. So I'm gonna take my calculator here. I'm gonna say, what's 5 times 127? 635, okay? And then we're gonna multiply 6 times a 4x. Well, 6 times 4 is 24, and I still have that x there, okay? Okay, so now I'm going to try to divide everything here by 24, okay? And I'm going to end up with, let's see, it's 9 and 5, okay. So again, here, y'all, it's not going to go in nice and neat, right? And you say, how do I know? So look, let's try dividing it by 24. Yeah, we get a decimal like this. It doesn't go in nice and neat. So again, we're just going to leave our answer as 635 all over 24. And that's where we'll stop, okay? All right. Now, for part D, y'all, I want you to notice the way the problem is written. It says 2 1/2 is to 4 as x is to 12. Okay, so when they're saying 2 1/2 is to 4, what they're telling me here, y'all, is 2 1/2 is going to be the top part, 4 is going to be the bottom part. When it says as x is to 12, I'm going to put an x on the top and I'm going to put a 12 on the bottom, okay? So the first thing I would show my 6th graders is I'd say, look, y'all, we've done this before, right? Y'all did this in 5th grade or something, but this is what I would tell my group of 6th graders. I'd say, look, how do I take 2 1/2 and write it as an improper fraction? And hopefully my students would say, sir, you're going to take 2 times 2, which is 4, add 1 more, that's 5. That's all over 2. This is 4, and this is x, and this is 12, okay? And I'd say, all right, guys, look, we're going to multiply straight across here. So we're going to take 5 halves times 12. And they're like, sir, how do you do that? So we're going to go really slow. We're going to go 5 over 2. I'm going to think of this 12 as 12 over 1, okay? And I would tell my students, aren't we going to have to do the same thing here? And hopefully they would say yes, right? We'd end up with a 4x, okay? Now, what I would tell my students is, remember, how do I multiply fractions? I go straight across. So I would go, okay, well, what's 5 times 12? That's 60. What's 2 times 1? That's 2, okay? And I might even put the little dot there because I don't want them to say, sir, why didn't you put a dot? There it is. Okay, and then we would say, what's 60 divided by 2? Oh, that's 30 equals 4 times x. And then I would tell my students, look, y'all, we're going to divide by 4 again. And they might say, sir, 4 doesn't go nice and pretty into 30. No, it doesn't. But we can reduce that fraction by dividing both the top and the bottom by 2, and that would give me a 15 over 2. Okay. Y'all, I definitely don't want to sound like a broken record, and I know that's an old expression, but I don't want to be repetitive. But I think the idea here is, remember, you guys are going to be teaching your classes. So whether you're teaching a 2nd grade class or whether you're teaching a 6th grade or 7th grade class, the idea is you want to be clear with your communication. You want to talk the students through the process, right? And, you know, when we're in college, obviously, you know, our brains are more developed and all that kind of stuff. But if you're dealing with, you know, anybody between the ages of 5 and say 13, I mean, let's face it, their brains are still pretty small, right? And so the idea is it's really all about the communication. How do you convey this to the student? You're going to end up repeating yourself a ton of times. You're going to go back, you're going to teach it, you're going to reteach it, you're going to reteach it, but that's really the idea, right? It's like, there's not this expectation that, hey, you know what, you know everything, you know, once I show you once, you already got it done, right? With younger students, we definitely are, you know, it's going to be a repetitive process, okay? Okay, so here's my next problem. Again, I'm thinking about this, y'all. I'm thinking out loud here, but I'm thinking about this like I'm dealing with a bunch of 6th graders. So when you're in 6th grade, you're like, I don't know, 12 years old or something like that, right? So the first part here says the ratio of boys to girls in a class is 4 to 5. What is the ratio of boys to all the students in the class, okay? So again, if I was talking to a bunch of 12-year-olds, I would say, look, the ratios of boys to girls is 4 to 5. So that, oops. So my first number is a 4. My second number is a 5. This stands for the boys. This stands for the girls. The first question I would ask my students is because the question says, what is the ratio of boys to all the students? So I would tell my students, I said, look, y'all, if there are 4 boys and 5 girls, wouldn't we have a total of 9 students? And hopefully they'd say yes, right? Okay, and now the second part of the question says, well, what's the ratio of boys to all the students? Well, there's still 4 boys, but the ratio would now be 4 to 9 because there's 9 people total in the class, right? And then when I'd come back to part B, it says, okay, the ratio of boys to girls in a class is M over N. Okay, say, look, M over N. Remember, this is the number of boys, this is the number of girls, right? And I would do the same thing, and I would tell my students, look, let's see if we can find the total. And I would ask my students, when we found the total in part A, what did we do? And hopefully my students would say, you know, sir, we added the 4 and the 5. Okay, well, what 2 numbers are we going to add now? We're going to add the M and the N, right? Whatever number that happens to be, I'm just going to add them together. So now my ratio of boys, well, there was M boys, and the total was M over N, right? Okay, and then when I would get to part C, I would read through the problem and it says, look, if 6 out of 13 of the class are girls, what is the ratio of girls to boys? Okay, so when they do this here, y'all, 6 over 13, these are the number of girls but the bottom number is the total, okay? So 6 out of 6 of the class, right? So it's girls to the total class. So the question is now saying, what's the ratio of girls to boys? Okay, so look, if we were trying to find the number of boys, we would have to take the total and we'd have to subtract the number of girls. So if the total is 13 and there are 6 girls, that would mean there's going to have to be 7 boys, right? And the question now says, what is the ratio of girls to boys? Well, there's 6 girls to 7 boys, right? And again, this would be the approach. This is how I would tell a bunch of 12-year-olds how I'm going through the process, right? And then I would give them a problem or two and see if they can work it out or have them work together and, you know, all that kind of fun stuff, right? 6th grade can kind of be a challenging age group, though. Okay, so y'all, the next couple of problems are, they're not difficult to solve. It's just how we set them up, okay? So the first part says there's approximately 2 pounds of muscle for every 7 pounds of body weight of a certain animal. Okay, and it says for a 161-pound animal, how much of the weight is muscle? Okay, so guys, what I would do is I would tell my students, look, we're dealing with proportions. So proportions means that one fraction equals another fraction, okay? And when I read through this first line right here, and it says, look, 2 pounds of muscle for every 7 pounds of body weight. So I would say, look, this is 2 pounds, that's muscle, and that's 7 pounds, but that's body weight. And then when we read the second part of the sentence, it says, for a 161-pound animal, how much of the weight is muscle? So that 160 pounds, that's the body weight. So look, if the body weight was going on the bottom here, the body weight's going to go on the bottom over here. And we're looking for how much of it is muscle. I don't know. I'm going to call that X, but that's going to stand for how much of it is muscle. And now we're very good. And now we're going to cross multiply just like we did before. Perfect. And hopefully, if you're, you know, hopefully your 6th graders would say the same thing, right? So, Miss, now we're going to cross multiply. You'd say, man, today is going out really well, right? So 2 times 161, y'all, should be something like, I think it's 232. 222. Yeah, 222 or 322, isn't it? Yeah, 322. My bad. 322 equals 7x, right? 7 times x, right? I don't want to say, sir, where's the dot? There it is. And then we'll go ahead and divide everything by 7. So let's divide that by 7. Let's see if it goes in nice and neat. It does. So how much of it is muscle? 46 pounds, right? That's how much of it is muscle. Right? Just trying to draw an arm, but my pictures are pretty bad. Let's pretend like we didn't draw an arm. Okay. All right. So the next part, right? And 6th graders do not care about what is the better buy because, you know, mom and dad buy the better buy, right? But it says, what is the better buy? 3 bananas for 63 cents or 12 bananas for $3.12, okay? So again, what would we tell the students? We say, look, we're trying to figure out how much, oops. Does 1 banana cost, right? So you'd say to your students, okay, look, let's take a look here. 63 cents. Remember, in terms of a dollar, that's 0.63, and that's 3 bananas. So we would take our calculators again, right? Oops. And we'd say, look, 0.63 divided by 3. So each banana is 21 cents, right? Or we would say, look, if we're going with the second one, where we can get a bunch of 12 bananas for $3.12, we'd say, well, look, let's figure out how much does a banana cost there, right? Divided by 12. And a banana here is only 26 cents, right? So which is the better buy? Well, hey guys, it's better to buy 12 bananas for $3.12. Oh no, it isn't, right? The other way around, sorry, my bad. It's better to buy the 3 bananas for 63 cents because you're only paying 21 cents a banana, whereas over here you're paying 26, right? Okay. And so again, y'all, these problems are all going to be kind of ratio and proportion type problems, right? So look at the next one here. It says on a map, 1/3 of an inch represents 6 miles. If two cities are 7 inches apart on the map, what's the actual distance between them? Okay, so I would do the same thing. I'd say, look, y'all, we're dealing with ratios and proportions here. So I'm going to go 1 fraction equals another one. So 1/3 of an inch is the same thing as 6 miles. Over here, we have the two cities are 17 inches. And you would tell your students again, look, y'all, if I'm putting inches on the top here, I'm going to put inches on the top here. This is going to stand for the number of miles, right? So again, we would cross multiply. So we'd say, look, 1/3 times x equals whatever 6 times 17 is, 102, okay? And then they would say, okay, well, sir, how do I get rid, or miss, how do I get rid of the 1/3? Hello, how do I get rid of the 1/3? And we'd say, look, y'all, the way I'm going to get rid of a fraction is I'm going to multiply by the reciprocal. The reciprocal of 1/3 is 3/1. So we're going to multiply by 3/1 on both sides. So those 3's are going to cancel, right? And then I'm just going to take 102 times 3, and that should give me 306. And that's the number of miles, right? But again, y'all, the idea here, again, this is the whole point of this class, and even for part 2, guys, is the whole point of the class is not me teaching you how to do ratios and proportions, because you guys at this stage, you've seen ratios and proportions before. And you might say, well, you know what, I forgot it. Yeah, but it's not hard to learn how to do a ratio and proportion, or what it is we're doing, right? The main goal of the course, y'all, is how would you present this to your classes, right? And guys, the one thing I really want to emphasize, because I know that when I first started teaching, I taught my first class, y'all, at it was UTPA at the time, but it was, UTPA at the time. Now it's UTRGV. I taught my first class there, y'all, in 1997. Some of you guys weren't even born yet, right? But when I remember when I taught my first class, guys, that whole semester, I would sweat like a pig because I was nervous. Okay, am I doing this right? Am I doing a good job? And I remember, guys, this is back in 1997, right? So we didn't have Microsoft OneNote and all this kind of good stuff, right? So I was actually up at the board, but I would have my notebook where I had all my notes, and underneath my notebook, I would carry a handkerchief, because every couple of minutes I had to wipe my face because I was sweating, and I was just nervous a lot, right? And I was actually like that for a couple of years. Guys, I'm not telling this because I'm trying to make you nervous. That's not the idea. The idea is it's going to be okay. Are you going to make mistakes? Yes. But is there going to be something huge? No, it's not. So even if you make a mistake, it's not a big deal, okay? The one thing you're going to do is the first couple of years that you teach, you're probably going to be a little nervous. You're probably going to be a little uncertain. But the one thing you really want to do is find somebody who you trust, find somebody who you can go to. When I taught at UTPA, I shared an office with another guy, and he had been teaching already for like 15 years. So he really helped me a lot. And other teachers that I had, I would kind of go back and think of what I did with them. But the idea here is, how do you do this? How do you explain this to your students? Okay. So look, let's take a look at the next one here. And it says, David reads 60 pages of a book in 50 minutes. How many pages should he be able to read in 120 minutes if he reads at a constant rate? Again, what I would tell my students, look, y'all, we're dealing with the proportions. So 1 fraction equals another one. Okay. And look what they tell me. We have 60 pages in 50 minutes. Okay. And now the second part of the question says, how many pages should he be able to read in 120 minutes? Well, if I know my number on the bottom here is minutes, then the 120 minutes has to go on the bottom 2, and that's going to tell me the pages, because that's the pages over here as well, right? And again, I would show my students and I'd say, look, y'all, we're going to take our calculators, right? Because we got big numbers here. We're going to take 60 times 120, right? Now, guys, if I was doing 6 times 7, I wouldn't tell my students, let's get our calculator. I'd say, hey, let's use our multiplication table or whatever. But we're doing 60 times 120. We end up with 7,200, okay? And then we're going to cross multiply here, and that's going to give me a 50 times an x. And then we're going to go ahead and divide both sides by 50, right? So that those will cancel. And we'll take 7,200 and we'll divide it by 50, and we're coming up with 144. And the one thing I would tell my students is that's 144 what? 144 chickens, 144 what? And we're like, oh, it's the number of pages, right? Because it's not, I mean, obviously being able to do the calculations is important, but remembering what was it we were looking for is also really important, okay? Because we're talking about two different things here. We're talking about pages and we're talking about minutes. And just again, to get the students to understand what it is we're trying to find, right? Okay, so guys, I'm going to kind of keep scrolling along here, okay? And let's take a look at this next problem. And it says, Alan, Betty, and Carol invested in a corporation in the ratio of 5 to 6 to 7 respectively. If they divide the profit of 29,700 proportionally to their investment, how much will they each receive? Okay, so guys, I'm gonna be honest with you. When we start dealing with proportions that are more than 2, like now we have 3 folks here, this is probably more of a 7th or maybe even an 8th grade problem. But again, there's nothing that says that you might not be teaching that, right? So that's why we're going through this stuff here. But just like we did before, y'all, this is just kind of me taking a little step back, right? So if I was going step back, Daniel's son, oops, that's not how you spell step. Okay, so if I was going step back, if we had a proportion of 5 to 6, where this was the boys and that was the girls, would you guys agree the total would be 11? Because if there's 5 boys and 6 girls, there's a total of 11 kids, right? So when I'm doing this one here, y'all, this is how I would do it. We have 3 folks. We have Alan, we have Betty, and we have Carol, okay? So the way I'm going to kind of write these things out, I know Alan is a 5, Betty's a 6, and Carol is a 7. But what's the total? The total just means add them all up. So 5 and 6 is 11, 7 more is 18, okay? So this is how I'm going to do this problem here, y'all. If we're trying to figure out how much Alan's going to receive, Alan's going to receive 5 out of the total of 18 parts, okay? Now, this is Alan, and that's the total. When I set up my first fraction, it tells me how to set up my second one. Total profit, y'all, was 29,700. So that 29,700, that's going to go to the bottom. That X is going to go to the top, and that's going to tell me how much money Alan's going to receive, right? So again, I would cross multiply. I would say, look, let's take our calculators, and we're going to take, let me move this to the side. We're going to take 5 times 29,700, okay? And that's going to give me 148,500. And then I'm going to take 18 times X, which is just an 18 times X. And then I'm going to divide everything by 18, right? So I can find X. So look, let's divide that by 18. And Alan is going to get $8,250, right? So right here, y'all, I would say, look, Alan is going to get $8,250, okay? Okay, now I'm going to walk you all through the same process, okay? And we're going to say, look, well, now we got to figure out how much Betty's going to get. Well, look at Betty's proportion. Betty's proportion is going to be 6 out of the 18 total. Betty's proportion, this is Betty, and that's the total. The total was still 29,700, okay? And I would do this part exactly like I would do the one that I did before. And I'd say, look, now I'm going to take 6 times 29,700, okay? So 6 times 29,700, that's going to give me 178,200. And then we're going to multiply here. Look, that's going to give me an 18 times X. And then we're going to divide everything by 18. I know I'm kind of running out of room here, y'all. I apologize. So we're going to divide that by 18. And Betty's going to get 9,900. Okay. Now, we still have one more person that we got to figure out. We got to find out how much is Carol going to get. Now, guys, we could do this a couple of ways, okay? We could say, look, Carol's portion is 7 to the 18. So look, I'm just going to write this over here on the side. So 7, that's Carol's portion to the 18, which is total. And Carol's going to get a certain amount of money, right? Oops. Come on, pen. To the 29,700, right? And we could do that same process like we've been doing before. But I want to show you something that I think might be a little bit easier. Think about the total amount of money that we have. The total amount of money that we have is 29,700, right? Alan's going to get 8,250. Betty's going to get 9,900. Wouldn't Carol get whatever's left over, right? So we could say, look, let's do this, right? And I would show this to my students because, and I would do it this way, y'all, because we've already done the first two using ratios and proportions. We know how to find Carol's part doing the same thing. But we might say, look, let's take 99 and let's add the 8,250. That gives us 18,150, right? We're going to subtract that from the total of 29,700. So 29,700 minus 18,150. And so Carol is going to get 11,550. And that's how much Carol is going to get, right? And I would probably, if I was teaching a group of 6th graders, I would probably find Carol's amount that way, just to let them know, like, look, I know we've done parts A and B, and I know we're kind of doing the same thing. But I want you guys to be able to think, right? And it's not that you doing it the other way would be wrong. It would be right. You'd get the same answer. But I want you guys to see like the big picture, right? And could you do it the same way? Of course you could, but we could also do it like this and we'd still get the same answer, right? And is one way better than another? No, they're both good ways, but just kind of trying to, get the big picture here, okay? All right, so look, y'all, we got another couple of problems here. Let's see if we can figure these out. And it says, Vana scored 36 goals in her soccer kicking practice. If her success to failure rate was 9 to 8, how many times did she attempt a goal? Okay, so first thing I'm going to do here, y'all, when I'm reading through this problem, I'm going to look at this because they did give me a rate here. Okay, so that's 9 successes to 8 failures. Okay, I want you to think about what's going on. Vana is at soccer, okay? So she's trying to make goals. So she made 9 goals, but 8 of them she missed. What I want to know, what was the total number of attempts, meaning how many times did she kick the ball? 9 times she made the goal, but 8 times she missed. Wouldn't her total attempts be 9 plus 8? She tried that 17 times, right? That's how many times she actually tried to make a goal. Okay, so her total attempts is actually 17. Okay, now when I look at the question here, it says, how many times did she attempt a goal? Well, let's think about it this way, y'all. She made 9 out of 17, right? So she made 9, she was successful 9 times out of a total of 17. That's the ratio that we're working with now, okay? So look, I'm going to put 9 over 17. Remember, that's successes, that's the attempts, okay? Now, the problem right here, the first part says, look, she actually scored 36 times. So that 36 is going to go on the top because that's how many times she scored, right? We're looking for how many times did she attempt to kick that ball, okay? Y'all, I'm going to do the same thing like we've been doing before. I'm going to cross multiply. So look, we're going to go 9 times x. Well, look, that's a 9 with a dot and an x. We're going to take our calculators because we got bigger numbers. 17 times 36. That's given me 612. And then the last thing we're going to do is divide, right? Because we've been doing this already. And you might get sixth graders like, sir, again, we already know we're going to divide. Well, I know. And that's what sixth graders do, right? They complain about stuff, but it's okay. We all did the same thing when we were in sixth grade too. And so she attempted 68 shots and she made 36 of them, okay? So again, a big part of it, y'all, is just reading through the problem, making sure that you understand it so that you can explain it to your students. So guys, this is just a little, I think we have 1, 2, 3, 4, we got a few more problems to do. Okay, so actually, let me do these and then I'll tell y'all a little something. But again, you know, the idea, guys, I love teaching. I've been doing it since 97. I can't imagine myself doing anything else unless, you know, I was like on tour with a rock band playing guitar or something like that, because I love to do that as well. I'm okay at it, but I'm not great. I'm a better teacher than I am a guitar player. But the main thing is just being able to communicate and communicate well. And it takes time to learn that stuff, okay? So again, the best advice I can give you is it's okay to make mistakes, okay? It's not a big deal if you make a mistake. All right, so let's go through the next problem here, and it says, look, an aircraft is approximately 245 feet long and has a wingspan of 196 feet. If a scale model of the plane is about 38 centimeters long, what's the model's wingspan? Okay, so again, I'm going to do the same thing here, y'all. I'm going to say one fraction equals another one. And it tells me when the plane is 245 feet long, that's how long it is, we have a wingspan of 196 feet. That's the wingspan, okay? Now, when I look at the second part, it says if a scale model of the plane is about 38 centimeters long, look, that 38 is going to go to the top because that's how long the model is. We want to know what is the wingspan, okay? Again, y'all, I'm going to cross multiply. So I'm going to say, look, 245 times x is the 245 with a dot x, right? 196 times 38, I don't know, I got big numbers again. 196 times 38, right? 7448. Okay, and then again, y'all, we're going to divide by 145. Okay, let's divide that by 245, boom, and we come up with 30.4. Now, y'all, I know we really haven't talked about decimals yet. We're going to talk about that in the next chapter, but not a big deal in that if we end up with a decimal, that's fine. This is just what you're going to tell your students. It's 30.4 centimeters long, right? Now, if my decimal was a decimal that didn't end like repeating decimals or non-terminating decimals, then you guys, we would, you know, the instructions would talk about rounding, and we would talk to our students about what does it mean to round? Is 30.4, is it 30 or is it 31? And it's neither, right? But it's closer to 30 than it is to 31. And we would talk about the idea of rounding. Like rounding doesn't mean it's this number. It just means it's closer to that number, right? But we would talk to our students about that kind of business too, right? Okay. So let's take a look here at the next problem, y'all. And it says, if Amber is paid $10 an hour for typing, the table shows how much she earns. Okay, so I'm looking at the table here, and it says, sorry guys, let me get rid of my email because it's going to keep dinging as long as I keep getting emails. Boom. All right. Okay, how much would Amber make for a 20-hour work week? Okay, so look, y'all, number one, this problem is pretty straightforward. They tell me she gets paid $10 an hour. So if she works 1 hour, she gets paid $10, 2 hours, 20 hours, 3 hours, $30, 4 hours, $40, so on and so forth. So if she were to work a total of 20 hours, right, wouldn't we just take 20 times 10? And so Amber would make $200, right? Okay, now when they ask me, what is the constant of proportionality? The constant of proportionality, y'all, is just her rate. How much is she getting paid? Well, she's getting paid $10, right? For every hour that she works, she's getting paid $10. That's all the constant of proportionality means. It just means for every hour you get paid a certain amount. More hours, more money; less hours, less money, right? And we know that kind of stuff. I mean, even if you haven't had a job, if you're young and you just haven't had an opportunity to work yet, but you know that if you work an hourly job, that's how it is, right? More hours, more money; less hours, less money. Okay. So here's my next problem. And it's, look, a car travels about 40 miles on 1 gallon of gas, while a truck travels 180 miles on 7.25 gallons of gas. Which gets the better gas mileage? Okay, so we're looking for like rates here, y'all. So the first one is 40 miles for 1 gallon. Okay, so the fact that this is already 1 gallon, I don't have much to do here, you guys, okay? Because if you take 40 and divide it by 1, you still get 40, right? What we need to do is we need to do that same idea over here. So look, we're going to take 180 miles and we're going to divide it by 7.25 gallons so we can figure out our rate. How many miles per gallon are we getting, right? So again, I would show my students, I say, look, y'all, we're going to take our calculators here because we got funky decimals and all that kind of good stuff. We're going to divide that out. Okay, so if you notice here, y'all, I'm getting a decimal that does not end. It's 24.82 and a whole bunch of other stuff, right? 0.827, whatever it happened to be, right? 8275, and it keeps going on. Okay, now the question is, what gets the better gas mileage? 40 miles for 1 gallon or 24.872 with a bunch of other change? Well, 40 miles per 1 gallon gets more gas, right? So that's the better gas mileage, right? Okay, let's take a look at the next problem here. Again, I'm doing the same process. It says Charlie bikes 34 miles in 2 hours, while Jane bikes 30 miles in 5 hours. Who travels faster, Charlie or Jane? Okay, so look, y'all, we're going to go Charlie. Okay. So look, Charlie can go 34 miles, and it takes him 2 hours to get there. So if I were to divide that out, 2 goes into 34, y'all, 17 times. That means that Charlie is traveling at 17 miles an hour, okay? And then I would do the same exact thing for Jane, right? So I would say, look, let's take a look at Jane. Jane's gonna go 30 miles, right? And it takes her 5 hours to get there. And I divide that out, yeah, that's gonna be 6, right? So Jane's going 6 miles an hour. Who's going faster, Charlie or Jane? Charlie, right? So guys, if I was doing this problem in my homework, I would say, look, Charlie, because Charlie goes at 17 miles an hour while Jane only goes at 6, right? And that, but again, that would be my process, right? But again, y'all, you know, it's not so much about me showing you how to do the problems because I know y'all know how to do it. It's more about how would you explain this to your group of 6th graders or 7th graders or whatever grade you're in. You know, who knows? They might have you teaching, you know, maybe not your first year, but they might have you teaching 5th grade GT class, right? So those students are a little more advanced. So you might end up doing something like that, right? And this is kind of stuff you would show them. But you would, again, the idea is how do you walk them through the process? How do you convey this to them, right? Guys, the other thing I'm going to mention is once you become teachers, you're going to have a ton of workshops. Some of them are going to be really helpful. Some are going to be a waste of time because even now, right, I've been teaching 25 years and I have workshops and some of them are really great and some of them are just a complete waste of time. Like, man, I could have been doing something more beneficial than sitting in on this, right? But what I will say is when you have opportunities to go to workshops, go to conferences, I encourage you to do it. Guys, there's so much stuff that I've learned just by seeing like one person present. And I'll show you this at the end when I'm done with this, and I'll record it just so that even those people who are on my online class, you guys will be able to see it as well. But there's something that I saw somebody present to me in 2007, and I still use it in my classes today. And it's for a particular class, but I'll show you guys in a minute, okay? But let me go ahead and keep moving here. Okay, let's see. It says there's 69 students in a classroom. The desired ratio of students to computers is 2-to-1. How many computers are needed to achieve the desired ratio? Okay, so look, y'all, first thing I'm going to do, I'm going to write this part out here as a fraction. Students to computers is 2-to-1. So that means there should be 2 students to 1 computer. Okay, so remember, one fraction equals another fraction with ratios and proportions, right? Now look what they're telling me. We have 69 students in a classroom, okay? So we have 69 students, right? The question says, how many computers do we need? So look, I'm going to put an X here for computers. Notice, y'all, students on the top, computers on the bottom, computers on the bottom, okay? So I'm going to cross multiply again, okay? So I'm going to go this way here. So 2 times X gives me a 2 times X. 1 times 69 is still a 69. I'm going to go ahead and divide everything here by 2. And I want you all to notice something in this problem, y'all. They are asking me to do a little bit of rounding here, okay? So look, we're going to take 69, we're going to divide it by 2. We're coming up with 34.5. Okay, so this is something that, again, I would show my students. And I would just say, look, when we're doing the idea of rounding, rounding just says, is 34.5 closer to 34 or is it closer to 35? And one thing I would tell my students is, look, y'all, when it comes to rounding, and we're trying to round to the ones position, which is a 4 here. So I tell my students, look, y'all, when it's a 5 or more, we're going to round up to the next one. So 5 and up, bump it up. So we're going to bump that up to a 35. So we need 35 computers, okay? All right. Similar problem coming on here, y'all. Again, this is probably more of a, again, still probably a 6th grade problem, maybe even a 7th grade. But it says, here's the problem. It says, look, the ratio of oblong tables to round tables at a conference is 2-to-3. Okay, so I'm going to go like this, 2-to-3. These are the oblong tables, and these are the round tables, okay? Now, it says the total number of tables at a conference is 45. Okay, how many of each type are there? Okay, so let's do this. Before I set up another proportion, let's do this. Would you guys agree that the total ratio then would be 2 plus 3, which is 5? Okay, so then we would say this. We're looking for how many of each type are there. So look, y'all, I could now set up a new proportion. I could say, look, there's 2 oblong for every 5 tables, okay? And at the conference, we have a total of 45 tables. We want to know how many are oblong, right? Like oval. Okay, and I would tell my students, look, let's cross multiply again. Look, 2 times 45. And sir, can I get my calculator? No, come on, guys. We can do 2 times 45, right? And then what about 5 times x? So look, that's just a 5x. So we would divide both sides by 5, right? And we'd say, look, what's 90 divided by 5? We'd come up with a total of 18. So there's 18 oblong tables, right? And then we would say, okay, well, look, we're still looking for the number of round tables, right? And they would say, you know, sir, we're going to set up a number proportion. I tell them, look, we can do that. But do you remember that we have a total of how many tables? 45, right? If 18 of them are oblong, wouldn't the rest, 27, have to be the round tables now, right? Because if there's a total of 45 tables, right? And if 18 of them are oblong, then how many are round? Well, whatever's left over, because we only got those 2 types of tables, right? I'm sorry, say it again. The 27? Because, so remember, there's a total of how many tables? 45, right? And if 18 of them are oblong, all I'm doing is I'm saying, what's 45 minus 18? And there's my leftovers, right? The 27. Okay. This is 6.4. Yeah, 6.4. Okay, look, guys, so that right there seems to be the end of 6.4. And again, I just want to show you guys something, y'all, because, and I'm going to do it like this. I'm going to come back over here. I'm going to go to my my drive here. I do this in my college algebra class, y'all. And I think it's here in chapter 3. I'm gonna try to open this guy up. But let me see. So in my class, y'all, in my college algebra class, again, and you guys, I think before you took this class, you had to take college algebra. So you may remember seeing this, maybe you don't, but we did some stuff dealing with parabolas and that kind of stuff, right? And so, guys, in college algebra, when you have the vertex and you have another point, you can always find the equation, right? So one of the things that I do in my college algebra class is I do this problem. And again, I saw this y'all back like in 2007. And it's a problem where there's a guy who gets shot out of a cannon. And it tells me, so as I read through the problem, and again, I do this with my students, but I say, look, there's a guy who gets shot out of a cannon. And it says, look, he flies an average distance of 160 feet and a height of anywhere between 60 to 70 feet, right? So what I do with my college algebra class, y'all, and again, the reason I'm telling you this is when you have the opportunity to go to conferences or go to workshops, especially if they're for teaching, right? If it's like, I mean, guys, you're going to have to go to workshops that you don't want to go to. I don't want to try to minimize that. But when you have an opportunity to go to workshops for teaching, go check them out. Even if out of 5 things, you only pick up 1, that's 1 more thing that you get. So look, guys, it says, look, the guy gets shot out of a cannon. He goes a total of distance of 160 feet. So the distance from here to here was 160. The height I would go with 70. And I would say, look, if this is 160, then the number in the middle is 80. So this number, that point there would be 80, 70. And then I have 2 other points. One of them is 0, 0, and the other one is 116, 0. And then we find the equation of the guy getting shot out of a cannon, right? But the other thing I would show my students, y'all, and let me see if I can pull this up also, is I'm going to go here, and I do this with them. Let's see. Here we go. And I show them the guy getting shot out of a cannon, right? And what does it do for my class? What it does for my class, y'all, it's like a little vacation. You get a little break of having to do math, and you get to see a guy getting shot out of a cannon, right? Let me see. And I think I have, here's another one. And I ask my students, like, how do you think somebody becomes a human cannonball? And there's a video here, guys, if you just notice. And the way this guy became a human cannonball, his dad's a human cannonball. Look, that's the dad. He's an old man. And he gets shot across the border. This is in Tijuana, Mexico, going into San Diego, California. And there's a guy, he just got shot over the border wall. And right, so it's kind of a neat thing, right? And who doesn't want to see an old guy being shot out of a cannon? It's kind of neat, right? But excuse me, my point though is that I do this in my class, right? And then there's other videos, guys. The main guy who gets shot out of a cannon, his sister is also a human cannonball, right? So right now in front of me, it's all girls in the class. Hey, girls are human cannonballs too, right? It's just a sort of a neat thing. But every time I've taught college algebra, and every time I started doing this, and I would look over my students, everybody's smiling. Why? Because it's kind of neat to see. And so those are the kind of things, y'all, that you pick up in workshops, that you pick up at presentations. Nobody ever really shows you that in a class. You know what I mean? Your principal is probably, and I mean, who knows? Maybe you have a great principal. Maybe they're going to show you something like that. But whatever it is you do, the objective always, and guys, and I'm going to stop recording because I'm talking too much here, but let me stop recording. Boom.